Hi guys, in our previous video, we studied about ladder diagram basic symbols, and made logic of some examples via using these symbols. And try to know how can we convert our electric circuit diagram into ladder diagram. In this video we will take a deep look on others bit logic symbols and blocks. Every brand of PLC software has normally same symbols. And via using these symbols we can design any complex program. First, we take a look on our previous examples. We have two switches and an output. Our purpose is when any input high, output will be high. If we draw this example in circuit diagram, it would be like this. And program of the circuit looks like this. Now we move forward. We have two push buttons and a bulb. And we are going to make a seal circuit. In this circuit, when we press start button, our output energized and bulb will on. And when we release the button, bulb remains on. And when we press stop button, output de-energized and bulb will off. When we convert it in circuit diagram it would be like this. When we press start button, our output energized and bulb will on. And when we release the button, bulb remains on. And when we press stop button, output de-energized and bulb will off. So, let's start to make a program in ladder logic. First, we place one normally open and one normally close contact in a rung. And then place a coil. Make a branch and insert another normally open contact. Make tags of contacts and coil. For making a tag, we require a physical address and a name. Here we see that we are using a contact of coil, for keeping bulb on. Now, save the program, download in a PLC. And now we will test the program via simulator. Here we are seeing that bulb is off, output coil is not energized. Check when we press start button, bulb will on, when we release the button, it remains on. And when we press stop button, bulb or output off. Repeat the program, bulb is off, output coil is not energized. Check when we press start button, bulb will on. When we release the button, it remains on. And when we press stop button, bulb or output off. Consider another example. We have 4 inputs and 1 output. Our program requirement is, when we press first button it will set the output and output will remain energized. Until we press any other button. We give some complexity and use one button as normally close, see what happened. First insert normally open contact and then we insert set rest block and then a coil. Now we place 3 buttons on reset pin. We place one normally close contact. In this design, when we press start button, our output energized and bulb will on until the fulfillment of requirement of reset pin. Make tags of contacts and coil. Now, save the program, download in a PLC. And now we will test the program via simulator. Here we are seeing that, output coil is not energized. Check when we press PB01 button, output will on. When we release the button, it remains on. And when we press PB02 or PB04, bulb or output off. Here see that for PB03, we are using normally close button, means when we press this button then we can set the output, otherwise not. Repeat the program. Check when we press PB01 button, output will on. When we release the button, it remains on. And when we press PB02 or PB04, bulb or output off. Now we move forward, let's take a look on an example. In this example, we have a tank with 2 sensors and a pump. Low-level sensor and high-level sensor. Low-level sensor indicates the empty level of tank. An high-level sensor indicates the high level of tank. And a pump is used to fill the tank. When we switch on our system, low-level sensor sense that tank level is low and it gives the command to pump to start. When pump receives the command from low-level sensor, it starts running and start filling water in tank. When high-level sensor detects the water, it gives stop command to pump, and pump stop until water low-level detection in tank. So, let's start to make a program in ladder logic. In our program network 01 made for whole system start-stop. In second network we use a contact of system started. And then we place a low-level detection sensor input. And then a coil. Now we make a branch for pump to remain running. Now we will give tags to each contact. And then place a normally close contact for high-level detection. Save the program, download in a PLC. And now we will test the program via simulator. Check when we start our system, pump is off, output coil is not energized. First, when we start our system, we press system start button. And our system started, coil energized. When low-level sensor detects that water in tank is low, it gives start command to pump. When pump receive command and start filling water tank. When high-level sensor detects the water, it gives stop command to pump, and pump stop until the detection of low level. Repeat the program. When low-level sensor detects that water in tank is low, it gives start command to pump. When pump receive command, it starts and start filling water tank. When high-level sensor detects the water, it gives stop command to pump, and pump stop until the detection of low level. So, guys, this is a simple program. We can use different symbols to make this program. It depends on programmer, how high use the symbols to make a program. Consider another example. We have 3 tanks. Tank 01 and Tank 02 have different colors. And a mixing tank is used to mix the color. When we switch on the system, low-level sensor of mixing tank detects the low level and give open command to valve 01 and valve 02. After receiving the opening command, valve 01 and valve 02 start filling the mixing tank. When high-level sensor of mixing tank detects the high level, it gives close command to valves. After that, our mixer pump start and start mixing the color for 10 seconds. After 10 seconds it stops and give the command to valve 03 to empty the mixing tank. Now we will make this program in ladder logic. Listen, guys. I have already told you that we can make programs in multi-ways via using different bit logics. So, it depends on programmer how he uses them here. First, open symbols table and define tags for all used inputs and outputs. First we define all inputs which we are using. And then all outputs. You can also define tags as your requirement. Now we move forward and try to make a program. Now we place a normally open contact and a coil in a network. Normally open contact is used for system start and came from physical input, and coil is used to tell us that system is started. Now we place another normally open contact in a branch to keep system started. Now place a normally close contact to stop the system. It also come from field. In our program network 01 made for whole system start-stop. In second network we place a contact of system started and then we place a low-level detection sensor input. And then a coil or output for valve 01. And similarly make a network for valve 02. Now we make a branch for valves to remain open. In next step, when high level detects the high level of mixing tank, it closes the valve 01 and valve 02. Now, We put normally close contact for high-level sensor in network 01 and network 02. After that, when high-level detection came, it gives start command to mixer for 10 seconds. Here we will use a timer for 10 seconds timing. Mixer run for 10 seconds and after that mixer stopped. When mixer timer stop, it give command to valve 03 to open for 10 seconds for empty the mixer tank. Use another timer for 10 seconds. Okay, our program is complete now. Save the program. Download in a PLC. When we monitor on, we see all outputs are off. When we start our system, system on. System started coil is energized. When we press again system start button, system remains started. When we press system stop button, system stops. Again press start button. Our system started. Now when low level sensor detects the level of water, it gives command to valve 01 and valve 02 to open. Valves start filling mixer tank. When high-level sensor detects the level of water, it gives close command to valves and start mixer for 10 seconds. After 10 seconds mixer stops and give command to valve 03. It remains open for 10 seconds to empty the tank. So, guys, you see how can we make the program step by step. You can also design any process. Look around and try to make programs. Start with simple logic. When you start making logic, consider your process. Find the know of inputs and outputs. And try to make simple logic using simple contacts. Guys, when you use inputs from any source means push button, limit switch, proximity, or etc. It depends upon you, how you use them. When you use normally close contact, remember the concept of relay. When we energize the relay, its normally close contact become open. And normally open contact becomes close. Same behavior you will see, when you use normally close contact. Now we take a look on timers. Every software of PLC use timers. Different types of timer are used in programming. Some of them are pulse timer, extended pulse timer, on delay timer, off delay timer, and etc. Every timer has different behavior and it depends on programmer how he uses them. Consider a program in which we attach different timers with a contact and try to look their behavior. Every timer needs a starting energized bit to start, and after that their working start. Look on first timer, which is pulse timer. When we make contact I2.4, its timing stated and output energized. Timer stops after completion of timing, but its output remain energizing until we open contact. Now look on second timer. When we close contact I2.4, it starts its timing and output remain energized until the completion of its timing. When its timing complete, it stops and output denergized. Now look on third timer, which is on delay timer. When we make contact, its timing starts, but output remain de-energized until the completion of timing. When its given time complete, its output energized until I2.4 remains close. If we open the contact in mid of its timing, it also stops. Now look on last timer, it is off delay timer. When we close contact I2.4, it start giving output but its timing does not start. When we open the contact, it starts its timing and gave the output until the completion of its defined timing. So, guys, you look how could we use these timers, depend on requirement of our program. For detail on timers we will make another video. Wait for next video. Now take a look on counters. There are different counters available in a software. Normally we use up counter, down counter, up down counter, and etc. When we put these counters in a program, their behavior look like this. In counters normally we need an on-off pulse for counting, a pulse for reset its counting, A pulse for presetting counter. Some brands offer some more pins on counters like PV. PV pin is used for presetting the counter, means counter value reach this defined value. Down counter preset and output stops. Consider in a program. We have already defined two counters. Up counter and down counter. And also tags are given to both counters. Now we test them via simulator. In up counter, we see when we press button it counts 1. It takes a pulse to increase counting. We can reset its counting via using its reset pin. Or preset during counting via its presetting pin. In down counter, we see when we press button it decrement the defined value. And when it counting reaches to 0 its output stop. We can reset its counting via using its reset pin. Or preset during counting via its presetting pin. For detail on counters we will make another video. Wait for next video. So, guys, in this video you have learned about simple digital logic. In next videos we will try to make more programs using combination of these bits. And will give you the information about analog values. And try to learn ladder logic more deeply. So, stay on channel, keep watching our videos. Thanks for watching.